Kai Chen. This is Lab 4 Part 1. Okay, so we are given a stepping sequence and 3 different input, which is enable stepping, the direction stepping, and the clock input to develop a more step machine. So following the requirement, we plot a step diagram where the enable and direction is equals to 1, the sequence will go clockwise. While the enable is 1 and the clockwise is 0, and the direction is 0, it will go anti-clockwise. And then we plotted a truth table. So from the truth table, we use 2 JK flip-flop to get 4 different output, and then in combination they will give 4 steps, which is in the step diagram. Okay, so let me show you the circuit. So when the enable is 0, the diagram will stop. When the enable is 0 and the clockwise, when the enable is 1 and the clockwise is 0, it will go anti-clockwise. But when the clockwise is 1, it will go clockwise. That's all.
Part 2, first part, which is the 3-bit linear feedback shift register. Okay, we are given the schematic diagram and we have plotted a truth table based on the schematic diagram. From the truth table, we found out that there are 2 sequences for this 3-bit register, which is 0, 0, 0 and this big loop. And this sequence is affected by X3. Okay, as you can see from here, when X0 and X1 is 0, and this one the X3 will get 0, and this loop will have infinite 0, 0, 0. Okay. However, when the ground here is changed to 1, and the X3 will be flipped and starts the big loop. Okay. And here is the schematic diagram, the design. Okay, from the DSO, you can see that this is the 0, 0, 0 state. When this one, the ground have changed to 1. Okay, and it will start the loop. Okay, and you can see from here, and this one, the oscilloscope we show is the X0 state, X0 output, and you can see there is a pattern for that, and it is a pseudo bit sequence, as the pattern will repeat periodically. Okay, and
so I'm going to explain about part 2. So from part 2, we are asked to build a 7-bit shift register by moving 2 wires only. So by doing so, we are changing the Q1 and Q2 into Q3 and Q6 because of the equation given. So on the DSO, we found that the X0, the new output of X0 is a pseudo random bit sequence.
this is part 3, and from the questions, we are asked to design a mini state machine to detect the sequence of 0, 1, 1. But first, we let the idle be the initial states, and when the idle receives an input of 0, the first element of 0, 1, 1 is detected, hence the state will move on to the next state, which is F01. When the state of F01 receives an input of 1, it will go to, it fulfill the second element of 0, 1, 1, which is this one, and it will go to the next state of F01. Okay, F01 is the last state of the sequence, and when the F0 receives an input of 1, it will give out an output of 1 because it's complete the sequence of 0, 1, 1. So it complete the loops and it gives an output of 1. and the loop reset and to receive a new sequence. However, during the every state, when the requirement is not fulfilled, for example, the ideal got 1 as the input and the F0 gets 0 as the input, it will loop back itself. When otherwise, and when the F01 receive the input of 0, it will go back to F0. Okay, and with this, we have plot out a truth table. Okay, and you can this have based on this state diagram. Okay, and based on this truth table, we have given we have know that when the dA is BW, dB is W complement, F the output is AW. Okay, and we will give you a demonstration by this. Okay, the output will give out 1 when the loop goes to 7th. Okay, because 1, 2, 3, 4, 5, 6, 7, it will give out a 1. Why is it 7? Because from the previous part 2, we know that the loop is the sequence is built out from 7 sequence, which is 1, 2, 3, 4, 5, 6, 7. Okay, that's all for part 3.